Welcome to the video lecture on ARM architecture. So today we are going to see ARM architecture. For any processor or a microcontroller, there are three main functions. One is fetch, decode and then execute. Okay, these are the three main functions for any processor to operate. One is fetch, decode and execute. What do you mean by fetch? Fetching a data or instruction from the memory. So in order to have this, I need program counter, address bus and then data bus. What do you mean by decode? Analyzing the instruction opcode, what the opcode represents, what the processor has to do with that opcode. So for that, I need an instruction decoder and the control unit. And final operation is that execution. So in order to do the execution, I need ALU, and in order to store the result, I need either register or a memory and data bus as well as the address bus. So there are three main functions of a processor. One is fetch, next is decode, next one is execute. We will see all this in detail by analyzing the architecture of ARM7. So what do you mean by fetching an instruction? Fetching an instruction means fetching an opcode or data from the memory. Okay, either we can fetch an opcode or data from a memory. What is an opcode? Opcode is operation code. So initially the address is loaded in the address bus and the program counter is incremented by 1. Okay, what is program counter? Program counter holds the address of the next instruction. Program counter holds the address of the next instruction. Hope it's clear. Program counter holds the address of the next instruction. So the current address is loaded in the address bus. It goes to the memory. The memory decoder will search where this address is and where the address is, and it points to the particular address. Then the microcontroller will send the appropriate control signal. Then the opcode or data will enter into the microcontroller through the data bus. So this is how the fetching happens. So I need address bus, I need control signal, I need data bus in order to fetch an opcode or data. So this is the architecture of ARM processor. So from the data bus, we collect either instruction or the data. If it is a data, it will directly go to the register file of ARM processor. If it is an instruction, it goes to the instruction decoder. Okay, so from the data bus, we can have either data or instruction. If it is a data, it enters into the register file. If it is an instruction, it enters into the instruction decoder. So fetching is over. The next operation is decoding. How a decoding takes place? When the opcode enters into the instruction decoder, the microcontroller will check what the opcode mean. What is an opcode actually? Each and every instruction will be represented in the form of a binary called operation code. In other ways, I can call it as opcode. Say for example, 36 is used for move A comma B. 42 can be used for move C comma A. Who give all this opcode? The manufacturer could have given all this opcode. So each and every instruction has got its own opcode. So opcode is given to the instruction decoder. The instruction decoder has a control unit which will analyze what the microcontroller has to do with this opcode. Okay, then it will do the execution accordingly. Then coming here, whenever the data comes, I told you it enters into the register file. There are 16 registers available in ARM7 starting from R0 to R15. Each register can hold 32-bit data. Okay, there are 16 registers in ARM processor. Each register can hold 32-bit data. Okay, but in between this data and the register file, we have another block called sign extent. What is the importance of sign extent? The data that is entering into the register file can be of byte, half word or word. What do you mean by word? Word has a size of 32-bit. Half word is a 16-bit. 16 bit and byte is a 8 bit. Okay, so what is the importance of sign extent? Your data that is coming from the data bus can be 8 bit or 16 bit or 32 bit. Is it clear? Is it clear? But the register in the ARM is what? How many bit is this? Is this 32? So whether it is 8 or 16 or 32, it has to be fit in the 32 bit register. So what it has happened, if it is an 8 bit, this has to be filled to become 32 bit. If it is a 16 bit half word, the entire this has to be filled in order to become 32 bit. If it is a 32 bit word, no problem, no sign extent is needed. So how can I fill this? How can I fill the remaining bits? Can I put a garbage value? No, I cannot put a garbage value because it will change the value of the register. So I cannot put a garbage value. Can I put all zeros or can I put all ones? There is a rule for it. So let's see an example. How do you represent plus 7? Plus 7 in terms of 8 bit 0 0 0 0 0 1 1 1. How do I represent minus 7? The minus 7 is represented by 2's complement. Am I correct? 2's complement. What is 1's complement? Changing 0 to 1, and then what is 2's complement? Adding 1 to the LSB. Adding 1 to the LSB. So minus 7 is 1 1 1 1 1 0 0 1. So when I wanted to represent in the form of 32 bit, you see the MSB bit. If the MSB bit is 0, extend 0 to the remaining bits. If the MSB bit is 1, extend 1 to the remaining bits. So look sign bit and then extend. Look sign bit and then extend. So if it is an 8 bit or 16 bit, I need a sign extend. If it is 32 bit, I doesn't need a sign extend. Hope it's clear. What is the importance of sign extend? Okay, and one of the speciality in ARM is that it supports triadic operations. What do you mean by triadic operations? For each instruction, I can use 3 registers. When I say add R0, R1, R2 means R1, R2 is the source register, R0 is the destination register. So what is the operation of add R0, R1, R2? It will add R1 and R2 and store the result in R0. But what is the speciality of this? Why can't I use add R1 and R2? It will do the same operation as R1 plus R2. Why not this? What is the speciality of triadic operation? When I use R1, R2, R1 it will do R1 plus R2 and store the result in R1. What will happen? The previous value of R1 will get erased. It cannot be reused again. So in order to avoid this, we'll go for a 3 register format or triadic operations. Now we'll move on to the architecture. So what I told you, the data from the data bus enters into the ARM processor. If it is an instruction, it goes to the instruction decoder, and then the instruction decoder will check the opcode and execute the opcode accordingly. If it is a data, it enters into the register, and ARM has got a 16 register, each carry 32 bit. Okay, if the data is 8 bit or half word or 32 bit, it needs a sign extend and it will go to the register file. Then what will happen? The two datas, one from A and the other one from B, will enter into the ALU. The ALU operation is performed and the result is stored in the register. Okay, so ALU will do the arithmetic and logical operation and the final result is stored in the register. Why? Because most of the operations or most of the data are available in the register, and the result can also be stored in a register, or it can be in the memory, So there is another block called bearer shifter. What is the bearer shifter? So from the register file, one data comes directly to the ALU, the other data is given to a shift. What is the specialty of this shift? It is otherwise called scaling. Okay, when you shift a bit towards left, it is of multiplication. When you shift a bit towards right, it is of division. So shifting makes your multiplication process very easy. Okay, so let's see an example for a barrel shifter. If the shift is 0, there is no shift at all. You see only the blue line. Okay, you see only the blue line. So what is this? Y0, Y1, Y2 and Y3. Okay, if the shift is 1, you see only the green line. Okay, so the first will be y1, next is y2, next is y3, and the third one is y0. If the shift is 2, see the orange color. So the first one is y2, next one is y3, then comes your y0, then comes your y1. See here, it is all shifting. So shift by 0, shift by 1, shift by 2, etc. So this shifting is nothing but a scaling. When it shifts towards left, it is of multiplication. Next, we have seen another block called MAC or MLA, multiply and accumulate. So we have done a partial multiplication or binary multiplication. The binary multiplication consists of two components. One is multiplicand as well as your multiplier. When you multiply, you will take the LSB and then multiply your multiplicand. Then you will take the next bit, you multiply it, next bit and multiply it. So you will get a partial product and this is your final product. So this is possible in the case of C programming. Any bit multiplication can be possible in the case of C programming. See here only one bit. Here the addition of 2 bits. Here addition of 3 bits. Here addition of 4 bits. Here another 3 bit, 2 bit and 1 bit. So any type of addition takes place in the case of C programming. But in the case of processor, any 3 byte or 4 byte addition is not possible. Why? Because I'll tell you an example. Why? Because when you wanted to add 9 plus 9, what is the answer? 18. 8 is the product, 1 is the carry. Say suppose I wanted to add 99 plus 99. What is the answer? 198. 198. So 98 is the product, 1 is the carry. Okay, when I wanted to add 9 plus 9 plus 9, what is my answer? It is 27. 7 is the product, 2 cannot be a carry. Am I correct? 10 cannot be a carry. I need only 1 bit to store the carry. So in such cases, addition of 3 bits is not possible in the case of processor. So what I will do is, whenever I multiply, I will accumulate. 2 bits multiplication is over, I will accumulate. Then from the accumulated data, I will multiply the third one and then accumulate. Here you see, I will accumulate these two. Then from the answer, I will accumulate these two. From the answer, I will accumulate these two. From the accumulated answer, I will add these. Am I correct? So in order to have an efficient multiplication, I need a MAC unit. So MAC unit consists of 3 inputs. One is multiplier, multiplicand and the accumulator, and the result is stored in the register. Okay, next, what I told you, after doing the ALU operation, the result can be stored in either in the register or in the memory. Suppose I wanted to store the result in 10 consecutive memory. What will happen? Initially ALU is loaded, ALU gives the address 4100. Okay, 4100, I loaded one data. Then what is my next consecutive memory address? 4101. ALU will give the address 4101 so that the result will be stored in 4100. Then I will go to 4102. ALU will give the address to the address bus 4102. I load the result. So every time I am disturbing the ALU. Instead of disturbing the ALU, whatever be the address, initially it can be loaded in an address register. It can be loaded in an address register. So when a 4100 comes in the address bus, the address register gets incremented it to 4102. Then once the 4102 2 is given to the address bus. The address register is incremented to 4103. Is it clear? Is it clear? So when we wanted to access the subsequent memory locations, I need a address register and a incrementer. I read an address register and an incrementer. I don't want to disturb the ALU. Don't want to disturb the ALU. But one question arises. There is a dedicated MAC unit only for multiplication. Is there any block for division? Is division is possible in ARM processor? Let's see. What is 3 divided by 2? It is 1.5. Am I correct? 1.5. Or what is the quotient? Quotient is 1, remainder is 1. But what I need, I don't want separate quotient and remainder. What I need is 1.1. ARM 7 does not support floating point number like 1 point. The point is not possible in ARM 7. ARM 7 does not support floating point number. So no division is possible in the case of ARM 7, which is a basic microcontroller. Hope you understood the architecture. Let's go for a recap. So what I told you, the three main operation in any processor or a controller is the fetch, decode and execute. So initially an operand can be fetched or data can be fetched. If it is an operand, it goes to the instruction decoder, and the instruction decoder will see the opcode and do the execution accordingly. If it is a data, it enters into the register file. ARM processor has got 16 registers, 16 register R0 to R15, and then this data after sign extend it can enter into a register file. So one data goes directly to ALU, the next data after scaling it enters into the ILU. After doing the ALU operation, what will happen? The result can either be stored in the memory or it can be stored in the register. Next, in order to speed up the multiplication, we have a separate MAC unit. In order to access the continuous or subsequent memory locations, I need a address register and an incrementer. Hope it's clear. Hope you have understood. Is it easy? Good. Thank you.